recording. Okay. So let's see what we are going to see today. We will solve couple of questions. Is it okay, Karthik, if I use Hindi? Hello, Karthik. Is it okay if I teach the things?
Yeah, no problem, no problem.
Okay. I think Pritam is also here, so then it would be okay. ठीक है, तो आज कुछ क्वेश्चंस करते हैं. पहला क्वेश्चन हम लोग करेंगे फाइंड द मिडिल ओके. सो हमको एक लिंक लिस्ट दिया रहेगा, हमको उसमें मिडिल एलिमेंट फाइंड करना है. ठीक है. ओके ओके, जस्ट गिव मी a second. I think I forgot. Now you can see my screen.
Yeah.
Okay. At the controls. Okay, so you will be given a linked list, for example 1, 4 and 5. Okay, and this last thing pointing to null, and you need to return this middle element. There is another thing, like if the length is even, for example 1, 2, 3 and 4, in that case again you need to return that there will be two middle elements, so you need to return the second last element. Okay, the kind of floor n by 2 of floor. Okay, कीप इट, इसको इंटरेक्टिव रखते हैं. ठीक है, आप लोग बोलते रहो. ये समझ में आया कि हमको क्या दिया रहेगा और क्या रिटर्न करना है? हेलो.
The linked list has 5 elements. Then the middlemost element should be taken. The linked list.
इंटरनेट में दिक्कत है क्या? हेलो, मैं ऑडिबल हूँ? प्रीतम, हेलो.
Hello.
इंटरनेट की इशू है क्या?
पावर कट हो गया.
ओके ओके, सॉरी, आई थिंक मेरे साइड से किया. ठीक है, कोई नहीं. ये समझ में आया कि हमको एक लिंक लिस्ट दिया रहेगा और उसका मिडिल एलिमेंट देना रहेगा. अगर उसका लेंथ ऑड है, इफ अगर लेंथ ऑड है तो स्ट्रेट फॉरवर्ड है, हमारे पास एक ही मिडिल एलिमेंट होगा. ठीक है. इफ लेंथ हमारा इवन है, तो देयर विल बी टू मिडिल एलिमेंट. तो हमको कौन सा रिटर्न करना है? सेकंड वाला रिटर्न करना है. कुछ क्वेश्चन में हमको ये रिटर्न करना है, कुछ क्वेश्चन में हमको ये रिटर्न करना है. वी विल सी हाउ वी कैन डू बोथ. ठीक है. एनी अप्रोच जो आप लोग के दिमाग में आ रहा है, हम ये कैसे कर सकते हैं कि हमारे पास ये लिंक लिस्ट है, हम इसको कैसे पता कर सकते हैं कि ये हमारा मिडिल एलिमेंट 3 होगा?
Length find out if we find out the length of the linked list.
Okay, for example,
Then
the length would be 5 over here, right? And in this case length will be 4. Okay, now what?
then if we could divide it by 2, then we will get the middlemost value, middle element.
5 divided by 2 is
Then it
actually
will,
2.
okay, the means seal element.
Like this 2 means 2 hop. Wherever you are, go one time next, and
Okay,
again one time next.
again. Okay, okay, okay.
Again here, what this 4 means? 4 by 2 is again 2. This means 2 hop. Wherever you are, go one time next, again go one time next, right?
Yeah.
This is kind of one approach, right? So how we will code this? How we will code this? We will given a function like get mid, okay, and we will give a node pointer to the head, okay. कुछ ऐसा दिया रहेगा हमको. तो हम व्हाट बी थिंक लाइक पहले हमने क्या सोचा कि हमको पहले क्या निकालना है, लेंथ. तो सबसे कैलकुलेट कर लेते हैं लेंथ. हेल्प करना आप लोग, कैसे कैसे करेंगे लेंथ, कैसे करेंगे इनिशियली. क्या होगा, we will check if head is already null or
So
not.
head is not equal to null.
If it's already null, then there is no middle element, okay. Return -1 just kind of like depends on question. Okay, but here we are assuming कि हम null रिटर्न कर देंगे. हम यहाँ से क्या रिटर्न कर देंगे, -1 अगर मिडिल नहीं हुआ तो, ठीक है. एंड अब क्या करेंगे, यहाँ से स्टार्ट करेंगे कि एक इंटीजर वेरिएबल लेंगे जिसे हम लेंथ डिफाइन करेंगे इनिशियली 1, ठीक है. 1 से करेंगे या 0 से करेंगे?
1 से कर.
1 से करेंगे क्योंकि अभी हमारा हेड पे एक है, तो हम जहाँ पॉइंट कर रहे हैं वहां पे है. तो एक टेम्परेरी नोड ले लेंगे पहले. नोड यहाँ पे ले लेंगे, फिर t इक्वल्स टू हेड, ठीक है. बाकी इन सारे क्वेश्चंस का लिंक मैं आपको डिस्क्रिप्शन में दे दूंगा, जहाँ पे वीडियो शेयर करूंगा. वहां से आप लोग प्रैक्टिस कर लेना. अभी बस यहाँ पे लॉजिक कर रहे हैं, आप लोग लॉजिक डिस्कस करिए एंड ट्राई टू सॉल्व इट ऑन योर ओन. And we will do while my t is valid, okay. What we will do, go t is equals to t of next, okay. And what we will do, length plus plus. We write it like this. हमने इसको ऐसे लिखा, तो हमको कहाँ से इनिशियलाइज करना है, 0 से, ठीक. If for the first node it will go to the next, count it, or we can just इसको ऊपर या नीचे कहीं भी लिख देंगे, दोनों में कोई फर्क नहीं पड़ेगा, कैसे भी लिख सकते हैं, ठीक है. एट द एंड क्या होगा हमारे पास, लाइक आफ्टर वी कम आउट ऑफ दिस लूप we will have length, okay. Now what to
Yeah,
do?
question is, I have a small doubt. Here we wrote while t is equal to head and t means while t, right? So means I did not get what is not why. I did not understand that part of that.
Okay, we can do
Means t.
not equal to null over here. Is it okay
Okay,
now?
okay, okay. I understood.
Initially in the previous class what I said is 0 false \0 and null all are same thing. All are same thing. Okay. So this will evaluate to true or false. That's what I want. Even sometime t will become null. That will also terminate the loop. So all are same according to C. Okay. Not in other languages, but in C, all these are same. If you try to print this or this, you will get only the value 0. Okay. So you can use like that. ठीक है. Now अभी हमारे पास लेंथ है. नाउ व्हाट इज द नेक्स्ट. अभी क्या करेंगे. हमें क्या डिस्कस किया था. लेंथ लिए. लेंथ पे क्या करना है उसके बाद.
by 2 करना.
बाई 2 करना है. प्रीतम आपको समझ में आ रहा है. अगर कहीं पे डाउट हो तो आप.
प्रीतम
ओके ओके एनीवे. What we will do, like I will do length equal to length by 2. Okay. Now we know these many halves we need to perform according to here how we saw it. Okay. If we get value 2, we will move our next pointer 1 and again means 2 times whatever value we will get over here, we will move that many hops. Okay. So how we can do that? You can either use for loop or while loop. Okay. This is multiple ways to write it, but how I write it in C++ is this. While L minus minus, first we need to again get the temporary thing. This t equals to head. Okay. Now what we will do over here. T equals to t dot next. I should have write t arrow next over here as well. Are you getting this thing? Why I again write this?
Why did you write L minus?
Okay, you what you can do is you can also write like this. You can write the same thing like this as well.
Hey, 1 second. I will tell you what I understood from the previous while loop. So when the second one in the box. So while the first t will be head, and when the t becomes 0, it will go to the middle most element. That's
No,
it, right?
not t, it's L. When L becomes 0.
Yeah, when L becomes 0, t will be in the middle.
Yeah, exactly. You can write the same thing like this as well. T is equals to t of next and L of minus minus. Okay, these two are exactly same thing. What I'm doing is I'm just doing this decrement part over here as a post decrement. Okay, this is post. So you can use either of this. At the end, what will happen? Your t pointer will point to the desired middle element. Okay? Middle element. Okay. So what you can do is make it as a comment. What you can do is simply just return the t, and you have your answer. Okay. So if I make it is in one thing. Okay. Did you got it? Let's dry run the code. What we are doing over here. Keep this only. Okay. We will, how we will find the length? What we will do? We will point our t over here is, we'll point our t over here, and initially L will be 0. What we will do? We will move this t by one thing. This is how like I'm just following what I have written in my code. I'm moving t to next and then incrementing the L thing and then checking whether it is null or not. I will increment L to 1. Whether my t is null? No, it's not null. It is pointing to 2. What I will do is I will again move my t to over here and again increment my L to 2. And I will again check whether my t is null or not. No, it's not null. It is pointing to 3. What I will do is again I will go to 4, increment the L thing to 3, and again I will check whether my t is null or not. No, it's not null. What I will do again is increment the t. I will move forward the t and increase the L by 1 to become 4. And now I will check whether my t become null or not. Yes, it's become null. Now in my L, I have value 4. Okay. This is how I get the length of the linked list. Okay. Then again, what I did, I got the L and divided its value by 2 and stored it again into the L. Eventually, what will happen? 4 will get divided by 2. My L will contain new value, that is the half of the length. L will contain 2. Okay. Now what I have done is I have wrote like this: while my L is greater than 0, what I will do, what I have written, initially I will point my t to head again. And how it's look like, my t will point over here again. What I'm doing is I'm moving the t by one step, t of next. And what I was doing, I was decrementing the L minus by 1. And this is what my loop looks like. So let's follow it. My t is pointing to head. My L is greater than 0. Yes, it is greater than 0. Its value is 2. What I will do is I will move forward the t pointer. What will happen? T will be pointing to 2 now. And I will decrement the L thing by 1. It will become 1. Now again, I will be here and checking whether 1 is greater than 0. Yes, it is. So we will again into the loop. And what we will do? I will move the t by one step. So again, we will move the t by one step. And again, what will we be check? We will decrement the L by 1. Eventually, it will become 0 over here. Now we will check here. Is my L is greater than 0? Is 0 greater than 0? No, this is false. So my loop will break over here. And wherever my t is pointing as of now is my desired middle element. Okay, what I can do, I can simply return the t from here. Okay, did you got it? Hello.
Hello.
Yeah. Did
So
you?
to find, yeah, one second. So to find the middle element, first we have to create a linked list.
Hmm.
After that, further create for the linked list we created, we should find the length. After that,
No, no, no. Linked list will be given. You don't need to create it. You will be given this head pointer, and you need to write this algorithm to get the middle element. That's it. You don't need to create the element. You don't need to create that linked list. It will be given to you. Okay.
okay.
Hmm. It's mentioned in the question. Like if you start doing the questions on some platform like HackerRank, LeetCode, or GFG, you will find they will be always giving the linked list. There will be some question where you need to design the linked list. In that, you need to write the insertion and deletion. Other than in most of the scenarios, you will be getting the linked list. Okay. Is there any other approach? Like, can you think of any other approach than this? What you did, you just gone through all the way and again you gone all the way to half, and then you find the element. In this way, you were iterating the linked list almost twice. Okay. Is there any better approach? Can you find the middle element while traversing? As soon as you get here, you get to know that this is my middle element. Okay, let me give you some context and you can think over it. Okay.
Okay.
Can you move one step and moving two step? Like moving one step and moving two step. Kind of take a pointer, move it by one step, and take another pointer, move it by two step. Okay. Just think about it. Someone is on the door and I will just coming. Okay. Just give me 1 second and think over it. I will come again.
Hello. I
Yeah, I'm here. Can you find
yeah
it approach?
yeah I got one idea like for every two steps
Hmm.
I take means the two pointer
Hmm.
is moved once and the
Hmm.
one pointer is moved once means when the t2 is on 2, t1 will be on 1. If t2 will be on 3, that means 4, t1 will be on 2.
Hmm.
So at the end, if t2 is on null, means and the end point t1 will be on the middle point.
Yeah, great actually. And this is what the approach is. So what this means is like why it works. If you are covering a distance, for example, a person is traveling, for example, 60 km/h. Okay. And like P2, and the person one is traveling half like half the speed, 30 kilometer per hour. Like in 1 hour, what will happen? Whatever the distance P2 will cover, for example, here, P1 will cover half the distance of it, right? Exactly.
Yes.
So this is the same analogy that we will use over here. What we will do, we will move the T2 twice as the speed of T1. That will make sure that as soon as I reach the end, my T1 will be half the way around, right?
Yeah.
Okay, let's try it, how we can do it. Okay, move T2 by 2 steps. Like first here and then here. For every 2 step of T2, what we will do? We will move 1 step of
T1.
T1. Okay. Again, we will move this T2 by 2 step and T1 by 1 step. Again, we will move T2 by 2 step.
T2 on the second iteration, if we move 2 steps, it should be on 5th one, right?
Okay.
It will be on 5th one and
Okay, it was here, right?
yeah.
I misplaced it. And now in second iteration, it will go here and it will go over here, right?
Yeah.
And then we will move it over here. Again, this is we will check whether T2 can move again 2 step or not. It cannot. Which one is the material element over here? This is the material element, right? Now from here, can T2 again move 2 step?
No.
No, actually. Okay. So as soon as you found that my T2 cannot move my another 2 step, the T1 will be at our answer, right?
Right.
Let's check the same thing in case of even as if it is working or not. Okay. My T2 is over here and my T1 is over here. Start moving it. We will move the T2 by 2 step and T1 by 1 step. Again, T2 by 2 step and T1 by 1 step. Okay.
Yeah.
Like here something fails, right? We cannot move T2 by 2 step, but we are not at our answer as well, right?
Yeah.
So can you check like what is the problem in this particular, how we can solve this? Over here, if we check, the T2's next is null, right?
Yeah.
But here T2's next is not null. We cannot move 2 step in here as well. We cannot move 2 steps over here as well, right? But in this case, my T2's dot next is null. But the other case, in the case of even, my T2's dot next is not null. So after I finished my loop, after I came at a point where my T2 cannot move any further, we will check whether its next is null or not. If it is null, that means it was of odd length and we come at the end at the final node and my T2 is at my answer. If this is not the case, then my T2 dot next is not null because it was of even length, but still it cannot move the 2 step. But where the T2 is pointing? It is pointing just before my answer. So if this is the case, what I will do? I will do T1 is equals to T1 dot next. Okay.
Okay.
this is what in odd case, and this is what in even case. Okay, let's try to write the code. What we will given, we need middle element, again get mid, we will given a node head. Let's take give it some logical name, example node slow. It will be pointing to head only initially, and similarly fast, it will again point to the head only. Okay.
Okay.
Now what? While we need to check
While
whether
fast not is equal to null.
yeah, fast like instead of writing not equal to null, we can simply just write it as fast. Okay, as I already
Fast.
told.
Okay. Yeah. Okay.
And what there should be fast dot next as well, right? And there should be fast of next of next. Okay, like if fast is here, in let's suppose fast is here, then it should able to, there should be a node at the next, and there should be another node to the next of it, right? Then only it can move to two step, right? So that's what we are checking here. Fast itself is not null, and fast next is there, and fast next dot next is also there. Then what we can do in this case is move slow by one step.
So next.
So dot next, and move fast by two step.
Next
Uh,
dot.
next, next. You can do it in two lines, but because I have done a check over here, that makes sure that it exists, so I can do again dot next, right? So now we need to check where we are, whether we are at this situation or we are at this situation. Accordingly, my T1 will change. Okay. Okay, let's see. We will check over here if fast.
Fast next.
Yeah, next.
And fast next.
No, just check fast.
No, it's fast next.
Next is there, means it's not null. Then my answer will be T1 dot next, right?
T1 dot next.
Then what I can do is I can just return T1 dot
Next.
and if it asking for value, then what you can do is T1 dot next of val, right? Depends on what question is asking. Else what we can do is just return T1. Okay. This is what code looks like. We are initially pointing to the same, and we will move one pointer twice as the speed of the slower one, and we have done some check that we got to know by seeing these things. Okay.
Okay.
Try this question on your own. If you feel any if you feel that you cannot do it or you are not able to code it, just let me know. I will explain all those. Okay.
Okay.
Okay, so now we have another question. Just give me a second. I'm getting a call.
Okay.
Yeah. Okay. So like this is kind of a hard question for you, but let's see what it says. Given a linked list, tell whether uh, it contains cycle or not. Okay. So what do I mean by cycle in a linked list? For example, 1 is here, 2 is here, 3 is here, 4 is here. Now again, this 4 is pointing to 2. Okay. Sorry. Did you understand the question?
Yeah, I understand the question.
So there can be two scenarios. One would be like the linked list is not cyclic, 3 and 4. That means it will be pointing to null. Then here is no cycle, and okay, it has cycle. Okay. How will you approach? Like, how will you tell whether the linked list has cycle or it don't have cycle? Any idea?
If there is no null pointer in the
How will
link,
how will you know there is no null pointer? Like you are just given this thing and this thing.
if I go through every link till the end, if at the end there is a null pointer, then I will say it is not a cyclic. If there is no null pointer at the end, or else if it is pointing to any previous thing in the array, then I will be saying it is
uh,
cyclic.
there is no array given, or you are just given the head of the linked list. And if you notice, there is no end of the linked list. You will come to 3. From 3 dot next, you will go to 4. For 4 dot next, you will again come to 2. Again, from 2 to next, you will go to 3. And from 3 to next, you will again go to 4, right?
Yeah.
So you will be looping here again and again and again. How will you know that it contains a cycle, or you come to know that there is an end and the end is joined into somewhere middle, joined to somewhere middle in the linked list?
Uh,
Not middle, actually, it can be anywhere. That means the last pointer is pointing to some element within the same linked list. How will you get this? This is pretty much like this is straightforward. While traversing, you found that you encountered null, and that is the proof that you don't have any cycle, right? But
yeah.
what about this?
When we started to get the repeated values, we could say no, we cannot say.
It can already have repeated value. For example, 3 can be over here. It was pointing to here and it can point into here. Now what? Think whether if you can store something, kind of like inefficient approach. Like I will store the address of this. I will come here and check wherever it is pointing and is the same address that I have used. If no, then keep going back or like keep going forward. If at some point you encounter null, then it is not pointing to something. And if at any point wherever it is pointing, is already stored in your hash map or wherever you want to store. That means it is pointing to itself, right?
Yeah.
Like this is what one approach would be. You can do this. Or can you think in terms of the same thing, the fast and slow thing? For example, you have a track of fixed length, right? For example, L, right? If one is traveling at like there is a loop, okay. If someone is traveling at half the speed of the other, okay, what will happen? Like this man is traveling, going here and going here and like keep going, and the other is going in a slow manner. Can you think in terms of this slow and fast thing? Again, let me explain you. Like, suppose there is a cycle, okay? No matter wherever these two start, for example, here's my fast pointer, just randomly I'm.
Okay, if they both meet at one point again, then the means if at any point they both point at one linked list, then it is a uh, cyclic linked list, or else it is not cyclic.
Okay, you said they will meet at a point, but what's the proof that they will meet? Are you sure they will meet? Like if one is going faster, another is going slower.
Yeah, I am sure. Means iterations might take, number of iterations might take, but at one point they both will meet at the same point.
Okay. Yeah, they will meet eventually. But what I wanted to hear is some little bit different. For example, my slow is here, okay? And this is my number line. If you say my slow is at, for example, let's suppose it's at 4.
Yeah.
My fast is uh at 1,
తీసేస్తున్నా 1 second.
3, 5, 6. Okay. I'm here and slow is here. What is happening? Like, what is the distance between fast and slow for now?
2.
It's 3. Okay.
Okay, 3. Okay, 3.
What we are doing, we are moving the fast by 2 and slow by 1.
1.
Now what will happen? What is the new distance?
2.
2. Again, what I'm doing, I will just move the slow by 1 and fast by 2, right?
Yeah.
Now what is the distance between them?
1.
1. Eventually what will happen? My slow will be here and my fast will go here and they will meet. Point. Okay. So if you see what is happening, if one is moving 2 step, okay, and another one is moving 1 step, right? Isn't it true if I say the fast pointer is approaching 1 by 1 step every time? Is it true? If in a cycle, if they are moving in the same direction, no matter where they start, the fast is approaching slow by one step every time.
Yeah.
So if the fast is approaching one step every time, there are finite number of steps, right? The length is finite. So they will meet after some k iteration, right?
Yeah.
Yeah. So this is the proof that they will meet. So what you need to do is move fast by two step, move slow by one step, and they will meet at some point. Let's try to do a dry run and make sure it is working. 3,
My lights are sorry.
5, 6, 7, and here it is, right? The null thing is straightforward. You can just check whether it become null or not. I'm not talking about that scenario. You can simply return that it does not contain cycle. I'm just talking about if it contains cycle. Okay, so what will happen? My slow is pointing to this, my fast is pointing to the same thing, right? Now again, do the same thing. Move the fast pointer by 2 step, once here and once here, right? And slow by 1 point, right?
Yes.
Again, what we will do, we will keep doing the same until they are either fast become null or fast or same. Fast or small, fast and slow become equal.
Equal.
One step and 2 step. It's pointing here now. Now what we will do, we will move this f by 1 pointer. Now make sure it's we are not by algorithm. We will not know when we come inside the loop. But here usually you can see we came inside the loop, right?
Yeah.
Again, what we will do, move the fast by 2 step, 1 step over here and the second step over here. And again, we will move the slow by 1 step over here. Same thing.
Right.
Again, move the fast by 1 and here. Okay. And we are at this point, but after we move fast, we are moving the slow. So what will happen? Slow will move forward over here, right?
Yeah.
But we can check over there as well. If it is become equal, then yeah, it's there.
Means
But
we could write a if condition stating if the fast is equal to slow, then end the loop. Else we could continue the loop
hmm,
by increasing s to slow to 1 point.
hmm. You can do, but it will not take uh, not much step, but yeah, let's keep doing this until my s comes to f, not f comes to s. Okay, we came here and again we will the way I explained you, because I'm moving, I started the f first and s after that, so my f came here and after that I will move s, but you can just check. Okay, take doesn't matter if you do multiple, they will get at the same place multiple times. Okay, come here and come here, move this over here. Okay, got. Now my
Yeah.
s approach to my f and they both are at same place. So yes, if this condition, if this situation is there, then we have cycle. Okay,
Yeah.
how we will do I need to write the code, or you want to try this concept on your own?
I will try once. If I cannot write the code, I will ask you.
Yeah, sure, that is really good for me as well. Like I can cover lots of concepts in a single video.
Okay.
Okay, and there is a follow-up question. Tell the junction point. Junction point. What do I mean by junction point? Now,
Where S and F meet.
yeah, there, no. SF, S and F met at some place. That is good. We can get this thing at any random place. That means we contain cycle. But what I want is you just tell me the node where they were, where that the fine last node of linked list is pointing into the middle. Give me one second. What I mean to say is you need to tell the node in the middle of linked list where the end is pointing, right?
Yes.
Hmm. How can we get this three? Any idea? Like this is the hard part of this question. How will you tell that this is the three is actually the junction point?
Before, as you said, if we could store the values, address of the where the linked list, we could find out if the loop is going to the same address.
Hmm?
Then, if we could store the value of the linked list and means the address of the linked list and the loop, the final element goes again to the link, the same address that we stored, we could say it is the junction point.
Mm-hmm. Yeah, we can do that, surely. So, but the space complexity of that approach would be big O of n. But we don't want this. We want something big O of 1. We don't want to store anything. We will just do the same thing, moving, and and we will tell that this is the node. It's hard to like get an approach really quick. If you can get, that's really great. Okay, let's suppose we are given a linked list, right? Okay, so there are some nodes. I don't need to draw every node so that I can generalize it, right? There is some this part, right? After that, we have some of this part, and after that we have a junction point, right? Where my x and y pointer met, where my slow and fast pointer was there, right? And again, there's some space, like there's some distance where after that my junction point is there. Getting this general view.
Yeah.
Okay. Okay, so let's suppose my length of this part is x, right? So if I start from here, after x moves, I will be at my junction point, right? I can assume.
Yes.
Hmm?
Yes.
And from this junction point, my meeting point is at distance y, right?
Yeah.
And from my meeting point, the junction point is at distance z. Getting all this?
Yeah.
So the length from here to here, I'm assuming there are x nodes, and from my junction point, there are y nodes, and where I met into the circle, from there my junction point is at z distance. Means if I move z hops from here, I will get my junction point, right? All these value I don't know. I just assume like these are the distances. Okay.
Yeah.
So like if I talk about my slow pointer, what will happen? Uh, it will what it will do? It will move x step, right? Plus it will move y plus z steps some k1 times, right? Means the slow pointer will rotate here some like one rotation means what? Y nodes plus z nodes, and it can move some I'm saying it will move some k times, right?
Yeah.
And what about fast pointer? We'll also cover the x distance, right, from here to here,
Yes.
but the number of rotation would be different, right?
Yes.
So these two are like number of rotation, and after that they will come to this part. They will cover this y part as well, right? They will
Yeah.
cover this y part as well. Because if we take assume it from here, from junction point, they will move some rotations, and after that they will travel some y distance so that they can meet. They both can meet at this point, right?
Yeah.
Yeah. So this is the actual relation. And now we know that my fast is moving twice as my slow, right?
Yeah.
So how we can rewrite this relation as x plus k1 y plus z plus y is equals to 2 times of x plus k2 y plus z plus y, right?
Yeah.
Let's solve this equation. X plus a1 y plus z plus y equals to 2x plus 2k2 y plus z plus 2y, right?
Yeah.
If we move this y to this side, means I'm just solving the equation.
Yeah.
K1 y plus
K1 y plus z is equal to x
y.
plus.
Yeah, I will move this thing as well to that side. I will bring this part to this side. Minus 2k2 y plus z is equals to 2x minus x plus 2y.
Plus 2y minus 1.
Okay. What we will get? K1 minus 2k2 y plus z. Okay. What we will get over here? X plus y. Okay.
Okay.
What else we can do over here? Let's break this thing. Like we can rewrite the same thing as k1 plus, sorry, not plus, minus 2k2 minus 1. If we add over here, what we can do? Y plus z plus y plus z. Am I right? If we like what I'm saying is, if I'm saying if I write 3 times of 5, I can rewrite the same thing as 2 times of 5 plus 5, right?
Yeah.
So like 3 minus 1 is actually 2. So what I'm doing, whatever this part is, I'm just subtracting from here and I can add this thing.
Yeah.
Like then what this will become? K1 minus 2 times of K2 minus 1 y plus z plus, if I bring y over this side, they will get cancelled out, right?
Yeah.
Z equal to x. Right? This is a constant value, right? This is some value. This doesn't depend on x, y, z, right?
Yeah.
I can write it as k. K times of y plus z. Sorry, it was not y plus z. Okay, this is y plus z. Okay, sorry. See. Equal to x, right? This is what
Yeah.
we have got so far over here. What this relation means? This means this x distance, right,
Yeah.
is some y plus z is actually, if we see what is y and what is z. Y, z, y plus z is what y plus
Junction point to the meeting point of slow and fast to junction point.
hmm. Yeah. So what this y plus z is, y plus z is, this is the length of cycle, right?
Yeah.
So from this relation, what I can say is that the length of cycle times some k value, if I add z into it, it will become the same as x.
Okay.
Like, do you understand this? X plus
Yeah.
k is the length of cycle. Length of cycle. If we add the z distance, means if this was y and this was z, right? And this was x, right? So
Yeah.
my x part, this part, I'm talking about this part, is actually some the length of cycle, like few rotations, and wherever I'm meeting, I will just add this thing, right?
Yeah.
So what insight you get from here? If I start from here, right? If I start from here, this point, if I will travel this distance, what will happen? If my this thing will rotate few times, some k times, right?
Yeah.
And it will also cover this plus z distance, right? After few rotation, it will cover this plus z distance and it will come here, and my x and this few rotation plus z is actually the same point, right?
Yeah.
So if I rewrite this equation again over here, k times of y plus z is actually x. What I mean to say is, if I will cover this tail part, right, while I will be reaching over this junction point, what will happen? My Wherever my junction point was there, if I move this one step, I will also move this one step, right? This is what this relation says. This
Yeah.
means as soon as I cover the x distance na, it will have cover some full rotations k times. It will again come here, k times of y plus z is like covering the whole length of cycle k times, and then because this distance is z, it will also go z steps forward, and eventually they will meet over here at the junction point, right?
Okay. So we don't know the value of x and z, x and z, right?
Yeah, we don't know, but this relation speaks a lot, right? This means that whatever the distance of x would be, we don't know the actual value. Whatever the distance of x will be, it will be same as few cycle length plus the distance z. Wherever we are meeting, from there at z distance, we will have our node, right?
Yeah.
Like, did you understand it fully? If you have any doubt, ask it over here.
So at the point of intersection means at the junction point, the z value will be 0. Means
Yeah. If
so
both the pointers meet over here, is na, your z will be 0 at that case. Here z again will be the 0, and your y will itself will be the length of cycle.
yeah.
Because
So k times of
k can be 0, k can be 1,
cycle.
k can be 2.
So k times of cycle
Plus
is plus the z value.
actually the same
Means
as k as x. Sorry.
the k times of cycle plus z value. The z value means the point of meeting of slow and fast
Yeah,
to the
from
junction.
to the junction. Yeah,
It should be equal to the length of x.
yeah, that's what I mean. This relation. So
Okay.
as soon as you get this relation, now you can solve the entire problem. What you will do is move your pointers the way you were moving, right? Okay, my slow is here, my fast is here, right?
Yeah.
Now we will dry run it. Yeah, now what I was saying, I will move my fast pointer 2 times, right? It's here.
Yeah.
Make it somewhat slower so that smaller, so I can move it easily. Okay, I move it 2 times. I move it 2 steps. I will move this thing by 1 step, right? Again, I will move it by 2 step over here, and again I will move this by 1 step. Similarly, keep doing this until they meet 1 step over here, 1 step over here. Again, move it by 1 step. Keep doing this until they matches. Comes over here, and they comes over here, right? We got our what point? Meet point.
Meet point.
Now, according to the relation over here, our the distance from meet point to that node is some cycle is same as the length from here to here, right?
Yeah.
So what we will do, now we got our meet point. I will start a pointer. For example, let's say T1 from here and T2 from here, right?
Okay.
Now let's start doing it. I will move this pointer by 1 value, right? And this pointer by 1 value.
Okay.
Am I doing something wrong? As I can see, I'm not getting my junction point as that value.
Yeah.
Okay,
You should be moving 2 points, right? Like 2 times the J value.
I
Means
think
the Y.
I have just misplaced my this pointer.
No, no, no. Yeah, I think you're right only. Means if we see the equation for every 1 point of x, there is y plus z times of k and plus z means more value of that is moving than x.
No, actually, as soon as we cover the x distance, right? This distance, it should be pointing to in here. Okay, this what this relation is. I'm doing something wrong. I just find a junction point and keep it there. I didn't follow the rule. I moved my fast pointer and my slow pointer would be approaching my fast pointer. Then only I need to stop. If my fast pointing approaching, then I don't need to stop. That's what a mistake I have done.
Okay.
In here, I have pointed out like you don't need to stop over here. You need to keep moving. This is how algorithm will work, right?
Okay.
I move my fast pointer. Now my slow pointer will approach. It's here, right? Again, I will move my fast pointer here and here. My slow pointer will approach one by one. Moving fast by 2 and slow by 1. Again, I move fast by 2 and slow by 1. Now, because I'm moving fast by 2, I stopped here, but my slow pointer should approach because I moved afterward. Initially, my fast is moving. What I will do, I will move the slow by 1, right?
Okay.
Now this fast by 1 and 2, and now my slow by 1. As soon as my only what I'm doing initially
Okay.
starting
So the number of
fast.
iterations. So the number of iterations the fast took, the slow should also take those many iterations.
It should not be a middle way like n+1 or n minus 1. Like fast just came to slow and you stopped over there. No, the if you're moving the fast by 4 step, your slow should also move 4 step. Then only this equation holds, right?
Okay. But
Initially,
according to what you said,
Hmm.
the fast and slow both won't have the same number of iterations
It's not
in
about it.
the.
I'm talking about steps. If I'm taking
Okay.
2 hops, I need to take two small hops for the slow. That's what I mean. Like
Okay.
eventually it will moving more than the slow. But if I'm like if the small
Okay.
the is a fast one is I have moved one time, then slow will should also move one time at least. Not at least it
Okay.
should also move same number of steps. The size of
Okay.
step is different, but the number of step is going to remain same, right?
Yeah.
So we got our junction point over here, right? Now, if you see from the relation, this distance is same as this distance, right?
Yeah.
If you see by your eyes, you can see that the distance are same. But I in computer we don't accept this thing. We will go like T2 is over here, my T1 is over here, right?
Yeah.
Make it smaller so that we can move it. What we will do? We will move the T1 pointer by 1 step. Again, we will move the T2 pointer by 1 step because now there is no 2 times of relation. They are just simply plus. Whatever this distance is, the same as this distance. Okay. just keep moving it. Again, move the T1 by one step. And again, move the T2 by one step. We got our meeting point, right? Again. So wherever they meet now, this is our junction point. Got the point?
Yeah.
This is our answer. So, any doubt? We studied one approach, slow and fast pointer, finding the middle element. We reuse that approach, add some a little bit topping of math, if you see, and we got our desired answer.
Yeah.
So, any question? Other than that, I don't have any other thing for today's class. This was the hardest problem that I was planning to discuss today.
Oh, okay. Yeah, I understood this part,
Hmm.
but okay. So when we go to algorithm,
Hmm.
the fast step means the same number of steps should be taken by fast and slow, and that is considered as y.
Yeah.
And from then, when they both meet, we could just start iterating T1 and T2.
Hmm.
So that when
That's
they both meet, the junction point will come.
hmm.
We'll find out the junction point. That's it, right?
Yeah. So this is what that relation mean. Whatever the distance we will cover, whatever if assume like in the example that I took over here, in that case x was smaller, right?
Yeah.
So let's suppose there was much larger thing. X was really big, for example 100 nodes, and the cycle would have been of 5 nodes, right?
Yeah.
It can be, if I share my, okay, I can talk it about verbally, if you can
Okay.
imagine. So in that case, you can imagine like when we will traverse those 100 nodes, right? Those 5 node cycle will be repeated multiple times, some k times, right?
Yeah.
So that is what k times x plus y length of cycle means. Those 100 node length is somewhat a few number of cycle, then wherever we were meeting plus the distance.
So at the time you are saying,
Hmm.
how will we know when to start the T1 and T2?
Okay, so wherever you meet at the common point, like your fast and slow pointers were moving, at some point of time you got to know this is my midpoint, right?
Yeah.
As soon as you got your midpoint, you don't need to do math now because that was just a proof that it works. What you need to do, again you start from one pointer from x and the other pointer where at the midpoint, right?
Yeah.
And start moving both the pointer by one step forward. Keep going forward, and at a point they will meet, and that will be your junction point.
Means for in this case, the T1 should be moving along with the cycles.
Yeah,
Means
that eventually the midpoint within the cycle, that's guaranteed. If the
yeah.
midpoint is not in the cycle, then you will be that linked list doesn't contain the cycle. That's why you will get at the end, like you will return that it contains no cycle.
Okay.
So one will be in the cycle and other will be
Okay.
as
So
per
the
the thing.
T2 until the T2 and the T1 meets, we
Hmm.
will be iterating continuously. So at one point they will meet.
Yeah, that's
And okay. And so until the 100 times T1 iterated, the T2 will be moving in circles there only for the 5 points.
exactly. You got it.
Okay. Okay. I understand.
So try this question if you want. I can share the link of this question. Like if you just simply search Floyd, like the name of this algorithm is actually Floyd. cycle detection. Like, I'm not the guy who calculated the math and got to know how we can do it. It was some other guy, Floyd, and I'm just explaining his concept over here.
Okay.
So you can type Floyd cycle detection practice question, or on lead code just type cycle detection, and you will get some question. If you don't get, just let me know. I can share the link of the
Okay.
questions.
Okay, I will check.
That's it for today. Anything else? Or if you can share this information with your friend so that they can also join and get to learn something.
Yeah, I am share. I will share. Sure.
Yeah, thank you. This is it
Thank
for today. Anything else?
No,
Stop
that's it.
the recording.